In this video lecture, we're going to discuss brute force. What is brute force? It is one of the most basic and simplest type of algorithm. In brute force, we're going to look for all possible solutions in a problem, and then we're going to choose the best solution. So that's the logic behind brute force. So what are the advantages of brute force? So we are guaranteed to have a solution for a certain problem. And brute force is applicable to a wide range of domain, and it is best applied in simpler and small problems. And it could be a benchmark for a better solution for this problem, for a particular problem. And we don't need to have a domain knowledge or an expert on that problem. We just need to have uh, the basic knowledge about that problem to solve it when we are using brute force. So what are the disadvantages of brute force? Yes, it is simple, but the problem is the worst case scenario. It could be n factorial, n squared, or exponentially growing when we increase the number of n. Okay, so it's an efficient algorithm. But aside aside from inefficient algorithm, it could be slow algorithm. When we implement it, yes, it is a solution, but somehow it's slow in solving the problem. Okay. And what are the examples of brute force? We already discussed what is searching, string matching in data structure, shortest path, and knapsack problem. So some greedy algorithm, some brute force algorithm are applied on this concept, on this different domain. So let's start with sequential search. So one of the brute force algorithm that we implement in searching is sequential search or linear search, wherein we're going to compare the desired or the value that we're looking for in an array of elements. So for example, we are looking for 8 in this array with 5 elements. So it will compare the value 8 to the first element. If it's not the same, it will go to the next right element. Then if it's still not the same, it will go to the next. And we're going to stop our searching if and only if the value that we are looking for is equal to the value on the array. If not, we're going to proceed until we're going to compare the values until we reach the last element. So that's sequential or linear searching. So what is the best case, worst case, average case? If item is present, definitely the best case is 1, wherein the value that we're looking for is on the first element, while the worst case it's on the last element of the array. So that's why it's n. But the average case is n over 2. If item is not present, best case, worst case, and average case are the same, which is equivalent to n. So as we increase the number of elements in an array, the worst case also increases. So that's one of the problem of sequential search. So if you want to view uh, a, a simulation about sequential search, kindly go to this website, cs.usfca.edu visualization/search.html. So we have two options here, linear search and binary search. Definitely just click the linear search and it will visualize how linear search or sequential search works. Okay, so now let's proceed with the string matching algorithm. So string matching algorithm is basically we're looking for a word or a pattern in a set of text. So for example, we have a text T, which is composed of how space R space U question mark. And we're going to look for the pattern P, which is R. So we have 3 letters for the pattern A, R, E. So how does string matching algorithm works? Actually, the algorithm that we're going to use is the naive string matching, which is an example of brute force. Again, naive string matching, wherein we're going to compare first the first letter of the pattern to the letter of the text T. So compare A with the H. If it's not the same, we're going to go to the next element in text T, compare with A. As long as they are not the same, we're going to proceed to the next element in text T. So on the fifth element, we have A. So A is equal to A. So now let's proceed in comparing the next element in the pattern, which is R. So compare with the next element after A, so they are equal. So now we're going to proceed with the third element of the pattern P and compare it with the third element after the A. So it's A, so they are the same. So therefore, we found R in text T. But in case if if we have a pattern AR, only AR is equal to ARE, we're going to proceed to the next element, okay, until we get the ARE in case if AR is not found in this location, okay? So the time complexity of string matching naive is big O notation and squared. But some books, some website, it is M times N, wherein N is the number of elements in a string T, while M is the length of the pattern. Just to simplify it, that's why we use N squared. And the auxiliary space is O at one, since we are not changing or we're not adding space when we are doing the search of string. Okay. And if you want to visualize how string matching works, the naive, so kindly go to who could that be, visualizing string matching, and it will give you an idea how the comparison works, okay, from between the text T or the text T and the pattern that we are looking for. Another example of brute force is traveling salesman problem. If say traveling salesman's problem, we are going to go to the different nodes in a map. As a travel agent, we want to go to the different nodes, different cities in a map. Okay, so we're going to look for the shortest path to traverse to all cities on the map. So that's traveling salesman's problem. So, for example, we have 4 cities, and these 4 cities is represented by this circle or by these nodes: city 1, city 2, city 3, and city 4. And they are all connected by a certain path with a certain distance. So in traveling salesman's problem, brute force, we're going to look for all possible paths from the start, which is 1, start city, which is 1, and traverse or go to the different nodes and go back to city 1. Okay, so basically we could have 6 paths. So based on the permutation formula, it's n minus 1 factorial. So 1 times 2 times 3 is equal to 6. And after getting the different path, okay, and after determining the cost of each path, we're going to determine the minimum cost. So that will be the shortest path. And we're going to choose that shortest path, our path, in traversing within the nodes in that map. Okay, so let's try. So I'm going to choose first this path, 1, 2, 3, 4, 1. And based on the map, so it will be 10, plus 35 plus 30 plus 20, and the total distance is 95. And second path could be 1, 2, 4, 3, 1, wherein the total path is 80, and another path is 1, 3, 4, 2, 1. Considering the distance, the total is 80. Path 1, 3, 4, 1, and the total distance traveled through this path is 95. And pip path 1, 4, 2, 3, 1. So the total path is 95. And last path is 1, 4, 3, 2, 1. And the total travel distance is 95. So we have 6 paths, and look for the shortest or the minimum cost or the shortest distance traveled. We have 2, 1, 2, 4, 3, 1, and 1, 3, 4, 2, 1. So as a traveling salesman's agent, we're going to choose among these two as our path when we going to travel within these nodes. From one, going to other nodes and go back to node 1. Okay, so that's traveling salesman. And the time complexity is n factorial. So definitely more nodes in the map, more time needed to solve the problem or know the optimized solution. Last and before we discussed the last example, if you want to visualize how travel assessment work, just go to visualgo.net and it will show how travel assessments works. Okay, so last example, finding the closest pair wise. So basically, we're just going to look for pair points wherein they have the shortest distance compared with the other paired points. And using the Euclidean distance, we could determine the distance between points. So using brute force, definitely we're going to get all the distance between points. So for example, distance between P1, P2, P1, P3, P1, P4, P1, P5, P1, P6, P1, P7, P8, P1, P8, P1, and P9. And we have P2, P3, P2, P4, P2, P5, P2, P6, P2, P7, P2, P8, P2, P9 until we get all combination of pair points. So after getting all the pair points, after determining the Euclidean distance between paired points, so by getting the smallest value, getting the smallest distance, that will be the closest pair points. Okay, so what is the worst case scenario? It is n squared. The more points we have in our Cartesian plane, have more points we need to compare. Okay, so we need more time to solve problems with more nodes. Okay, so that's closest pair points. And that's it for the brute force. See you on the next video lecture. Thank you for listening.